Hello students, today we will talk about vernier caliper, the very important experiment in 11th physics. This instrument is known as vernier caliper and the name is given according to the name of French scientist who invented this, mathematician Mr. Vernier. So the device is known as vernier caliper. This device can be used in many ways to measure diameter of some cylindrical body, spherical body like this. If you want to measure diameter of this pen, then you have to insert the pen here and fix it in between the jaws by rotating this wheel. And if you want to measure depth of a cylinder, depth of cylinder like this, depth of this cap, then use this rod and do like this. Insert this cap up to full depth inside the cap like this. Then you can measure the reading from here. By using this rod you can measure depth. And third use is you can measure internal diameter like this. If we have to measure the internal diameter of this cap, then use these two teeth, then fix this cap, insert these two teeth inside the cap like this, and then open the jaw like this up to full value like this. Now you can measure diameter of this cap by using these two teeth of this vernier caliper. Okay, now let us come to the topic how vernier caliper is more precise than foot scale. My dear students, ignore this. Then this is a foot scale, simple foot scale having value in centimeter. You see there are 10 divisions in 1 centimeter. So it can measure up to 1 by 10th centimeter, either you can say up to 1 millimeter, normal foot scale. But when you use this vernier scale, if you are using this vernier scale, then you can measure up to 2 decimal point. So more precise value in 2 decimal point. If you measure the value in 2 decimal point, it is more precise, more accurate. So to measure the value, very simple. See this vernier scale, this is vernier scale, this bracket scale, here divisions are marked. These divisions are known as vernier scale, and this is main scale. This one is main scale, and this is vernier scale. These divisions are marked, and count very carefully. In these 10 divisions, 9 divisions of main scale are covered. So we have to start writing from here. 10 vernier scale divisions is equal to 9 main scale divisions. So value of one vernier scale division is 9 by 10 times of main scale division. Now least count or vernier constant. What is the least count? Least count is the minimum value measured by an instrument. That is known as least count. So least count is 1 main scale division minus 1 vernier scale division. That is the least count. Put this value here. So this is 1 main scale division minus 9 by 10 main scale division. So least count, either you can say vernier constant is equal to 10 minus 9 upon 10 main scale division. Either you can say 1 by 10 times of main scale division. And my dear students, this is the main scale. In 1 centimeter there are 10 divisions. So 1 division equal to 1 by 10 centimeter. So this is 1 by 10, 1 by 10 centimeter. So least count of this instrument is vernier constant, either you can say 0.01 centimeter. This is the least count of this instrument. Vernier caliper, this instrument least count is 0.01 centimeter. Now come to the reading point. First of all, we have to check zero error. Zero error. What is the zero error? Zero error may be some due to instrument imperfections. So press this button or rotate this wheel and join both the jaw. Okay, you will see this first line. Okay, I want to show you this first line. If this first line after joining the jaws, first line of vernier caliper is ahead of zero of main scale, then this is positive error. And if this first line of vernier caliper, this bracket is known as vernier caliper. If the first line of vernier caliper is behind this zero of main scale, then it is a negative error. And point to be noted, at last positive error is subtracted and negative error is added. Positive error, my dear students, positive error is subtracted from final reading and negative error is added in the final reading. So like this we can see positive error and negative error. So in this my instrument, let me join both the jaw and I will find if zero of vernier scale coincide with zero of main scale, then there is no zero error. But in my this instrument you can see if possible, I want to show you this first line of vernier scale lie ahead of zero of main scale. So there is positive error. Now what to do? Check out which line of vernier scale become straight with main scale. There are lines on main scale, there are lines on vernier scale. Check the count of the line which becomes straight with main scale. So in this my instrument, I find out sixth line, if possible, sixth line becomes straight. So there is a zero error in this instrument. There is a positive zero error equal to count of the line, number of the line, count of vernier line into list count. So here it is 6, list count is 0.01. So there is 0.06 centimeter positive error. We have to subtract this value at the end. We have to subtract it. Now let us come to the topic. How we'll take readings? It is very simple. You have to take 3 readings and then take average. Okay, for example, let me measure diameter of this pen. Okay, then I have to fit the pen here in the jaw, completely fitted, and then you can see how to take reading. Learn to take reading. This is the zero of this first line of vernier constant. This first line of this vernier constant is the zero of vernier line. It lie between 1.3 to 1.4 centimeter. If possible, see here, see this you can see here this first line of this bracket, vernier bracket, lie between 1.3 centimeter of main scale. You can see main scale reading, just like on foot scale. See where this first line touch on main scale. It is touching here on one point between 1.3 and 1.4 centimeters. So I will consider 1.3. So 1.3 centimeter. Secondly, very simple. Now we have to check which number count of vernier line becomes straight line with main scale division. So it is here in this instrument which I carry. I think it is line number 3. Line number 3, you can see line number 3 becomes straight. See what happened, like this. There are lines on vernier scale. This is main scale. This is main scale having many divisions, 1 millimeter divisions. This is your vernier scale. This is vernier scale, or and the this is the vernier scale. This is vernier scale, like this, like this. But in my case, the line number 3, 1, 2, 3. So 3 number line becomes straight. This count number 1, 2, 3. It becomes straight with main scale division. Both become like this in same line. So count that number. It is here 3. So reading formula is this: main scale reading 1.3 centimeter plus vernier scale division, it is 3 in count into least count 0.01. So this value is 1.3 plus 0.03. It is 1.33 centimeter. And now corrected diameter, you have to subtract this positive error. So corrected diameter is 1.33 centimeter minus 0.06. So it is 1.27 centimeter. You have to take 3 readings like this. Very simple experiment. And so my dear students, if there are 2 more experiments you can also perform by using this instrument. One is, you can measure internal diameter of a cap like this. Fit this cap here in the jaw and like this, and measure this value from here. Main scale reading plus vernier scale reading into least count. Very simple. And if you want to measure depth of a cylinder, then what to do? Use this rod. The rod attached to this rod. Insert this rod inside the cylinder whose depth is to be find out, and then take reading from here. From here you can take reading. So at last, how to take reading? Once again I am going to repeat the formula. Now these readings are more or same. Okay, you have to take 3 readings like this. This is the one reading. Second reading, okay, let me complete the experiment so that you can write it on your file. Now let I am taking now second reading, my dear students. Now second reading is, how to take reading? See, very simple once again. It is main scale reading does not change. It is 1.3 again. Now only vernier scale reading may be different. Now check which line becomes straight with main scale, which line become exactly straight with main scale. And it is here Now in this case, sixth line, I can show you. Sixth line becomes straight. So it is 6. So reading formula is main scale reading, very simple, plus 6 into list count. List count is 0.01. So it is 1.36 centimeter, and corrected value is 1.36 minus 0.06, 1.30 centimeter. Now third reading, you can write the same readings in your copy, practical copy. Okay. Third reading, my dear students, again I remove the pen, again I insert the pen inside the jaw, and again main reading will not change. See, it is the first division of vernier caliper lie exactly on 1.3 centimeter. So it is 1.3 again. Now check which division, count of the division of vernier scale, this vernier scale becomes straight with main scale, and this time it is fifth. Okay, 5. So reading formula is main scale division plus vernier scale division into list count. So main scale is 1.3, vernier scale 5 into list count 0.01. So it is 1.35 centimeter, and corrected value is 1.35, positive error subtracted 0.06, it is 1.29 centimeter. So the observed diameter of the pen is 1.27 plus 1.30 plus 1.29 divided by 3, this much centimeter. So like this we can perform vernier caliper experiment, very simple. Okay. Or what is the list count? List count is the minimum measurement taken by an instrument, that is known as list count. Okay. And my dear students, if you want to find out error in this value, you add these 3 values and divide by 3. Suppose this value come out 1.28 centimeter. Okay. Then what is percentage error in this reading? Percentage error formula is list count upon measured value 1.28 into 100. And what is list count? 2 decimal point value minimum measurement taken by an instrument, and that is 0.01 upon 1.28 into 100. This is the percentage error in our calculation. Okay, goodbye. Let us meet in next video. Screw gauge. I will perform the experiment of screw gauge. I think you understand very well. If there is any problem, then you can message me. Thank you.